Hi, my name is Smbad. Today we're going to solve LeetCode question number 1569. So this question is about getting the number to reorder number of ways to reorder array to get same binary search tree. So first of all, this question I think we all read this question description. So this question asks to us theoretically to construct binary search tree from given array. So then we have to reorder this array to get the same binary search tree. So there can be various number of ways to get this same binary search tree. So we just have to return all of the possible ways, a number of all possible ways. First of all, also this question asks to return us number in modulo. What does modulo mean is just in competitive programming, we just divide given number or solution when we return divide and return the remainder of this number, so that when our solution gets very high numbers, when it overflows, so that we can check the results exact numbers. Therefore we divide by this number. It's 10 to the power of 9 plus 7. So let's dive into solution. So first of all, we understood the problem. Next, I think if you are solving hard question, we all know what is binary search tree. But again, let's briefly cover what is binary search tree. So basically, binary search tree, it's just a binary tree with some property. For example, we have some root node with numbers, let's say 3. Then if we add next number to this binary search tree, if it is for example, will it be 7? So if it is 7, if you add this number to this binary search tree, it will go to the right because it's greater than 3. So it goes to the right. Next number, for example, it will be, okay, let's it be 1. So 1 is less than 3, so it goes to the left side. Therefore, this is called binary search tree. Again, if you add another number, for example, minus 100, minus 100, we again see is it greater than 3 or less? So it's less than 3. Okay, we go to this node. If it is again less than this value of this node, actually we can see that it is less, so it goes again to the left side. So in this manner we construct the binary search tree. Okay, so let's go and try to explain the examples. For example, we have the first example is when we have numbers like 1, 2, 1, and 3. It's our array. So we have 2, 1, and 3. It's our array. So let's construct binary search tree. So first number will be 2, then next number will be 1, so it goes to the left because of property of binary search tree, and next 3 goes like this. So from there we can see that 2, 1, 3 forms this binary search tree. Again, we have to form this binary search tree, but we can reorder the numbers in a possible way. So I can see that there is also one way. So 2 have to be first, because if it will be 1 first or 3, we cannot construct like 3, 1, 2. Why? Because there gets 3 first of all. So when we construct binary search tree from this array, it goes like this: 3, then goes 1, and then goes 2. There is a completely different BST, so we cannot construct it like this. Therefore, let's construct in another way. So we can construct, so 2 have to be first. So we write 2, then next 1 or 3, it doesn't matter. It can be 1 or 3. So in this example was first 1. Therefore, let's write 3, then 1. So this is our next way of writing this array. So if we construct the binary search tree again from this tree, we will get 2 first, then 3 is greater than 3, so it goes to right. 1 is less than 2, so it goes to left side. So in this example, we have only two ways. But when we return answer, it will be 1. Why? Because first way is already present in our example. Therefore, it goes like this. Next example, it gets like there is a 3, 1, 2, 4, 5. So our array is 3, 4, 5, 1, 2. Let's solve this again. Let's write this example. 3, then gets 4, then gets 5, then gets 1 and 2. There is a lot of example, like there is a 5 different ways other than our example. Our first way, there is 5 another ways. There is explanation, like let's again construct our binary search tree. It's 3, then it goes 4, then it goes 5, then it goes 1, 1 goes in this side, 2 goes there. So we construct the same binary search tree. So is there another way to construct this same binary search tree but with another array? Yes, there is a way. We can determine it like this. First of all, let's see which numbers are less than 3. There is two numbers is less than 1 and 2. So like let's show it here with red. This is our 1, this is our 2. And the greater numbers will be in yellow. This is 4 and 5. These numbers, when we reorder the array, have to be in same order. So like red ones, 1 and 2, like 1 and 2, they have to we have to write the array in the same order. Like 1 and 2 don't have to replace each other. So we cannot write 2 and 1 or in other order. But we can write, for example, first of all 1 and 1 and 2, then we can write 4 and 5. This is allowed. Why? Because first of all gets 3, and then 1 and 2 gets in the left side. So this is our another representation of this binary search tree. We can represent it in this fashion. So there is another ways, like we have to just reorder this 1 and 2, 4, 5 in these 4 places. There is a 4 places. So we can order this in other ways. For example, 4 gets this way, then 1, then 2, then 5. Here we can see that it's another representation of our array, but it constructs the same binary search tree. Why? Because 4 and 5 are locally 4 and 5 are in the same order, and 1, 2 is again in the same order. Like locally it's in the same order. We cannot write like this: 1, 5, then 2, 1, 4. These two numbers, 1 and 2, have to save their order. Like first 1 have to be first, then have to be second, and 5 we cannot write like this. So let's. So how can we solve this problem? To solve this problem, we just have to find the root number, the first number. When we will solve this question, we will use divide and conquer strategy. So we will use recursion as it can be seen from the problem. So first of all, we just use 3 and 4. We first write root, so it's 3. Then from this array, we determine the numbers which are greater than 4 and 5, which are greater than 3, which are 4 and 5. We write them in different array. This will be 3 and 4, 4 and 5. Then we will write numbers which are less than 3. We will determine these numbers. So this will be 1 and 2. And we will write these two numbers, these different numbers in two different arrays. Why we need this? Because we will create a method or a function which we call recursively. Each time it will find new orderings, new number of ways to count in how many orders we can in how many ways we can reorder our binary search tree, our array. So, for example, let's dive again into this question. Like, is there another example? Here's only one example with number of outputs 0. So let's again solve this question, but in another fashion. So what we will do? First of all, we have our array. Array is giving us 3, then it's given 4, 4, 4, 5, 1, 2, 5, 1, 2. So this is our array. We will take our root. So the number of lengths of this array is 5 lengths. Or let's write it like size. It's 5. So our root is 3. Okay. So our root is 3. So we have left 4 places. In these 4 places, we can we can place 4 and 5, 1, 2. So let's create new array. Let's write it less, for example, and it will contain, we will count them, it will contain less, so it means numbers which are less than 3. So it will be 1 and then 2. This array will contain 1 and 2. Next, our array is greater, so it will contain numbers 4 and 5. So there we will count, we will find the number of outputs and number of ways of reordering by using formula of permutations. So it's basically, we have to place this 4 and 5, like we have 4 locations, 1, 2, 3, 4. So there is a 4 locations. We can place 1 and 2 or 3, 4 and 5. It doesn't matter what, or where we put them. So we can think like we have 2 coins, like 2 coins, 1 coin and second coin. How many ways we can put these coins in these 4 locations? So this is called like permutation. So it's symbol is like C, and here's N, like 4, from 4 locations and the 2 items. The formula is like this. Let's write, it will be 4, 3 divided by 2 and 1. So it's 6. The formula is like this, N, R. So N factorial divided by N minus R factorial and R factorial itself. Why it's like this? Because first of all, let's think first coin. About first coin, this will be second coin. Where we can place this first coin? How many ways we can place this for first coin? There is a don't think that these first and second coins are different. No, they are the same. So I'm just showing that this we are searching for the first coin. So we have 4 ways because we can place it here or here or here or here. Therefore, we have 4 locations. 4 multiplied by. So after we placed the 1 in any of these locations, we have second coin. So we left with 3 locations, 3 places. Therefore, we multiply by 3. So we get 12, but we have to divide it by number of coins, not number of coins, but the number of coins and its factorial, like it 2 factorial. Why? Because these 2 coins are not, they are not different. If they was different, there will be not 2 factorial, there will be 12 combinations. But there is two coins and they do not differentiate. Therefore, we have to put this formula. So how can we solve this question? Like it gets like root to 3. So there will be C of 4, 2 number permutations. Then we multiply by individually these arrays like 4 and 5. Like this array itself can be reordered theoretically. Again, in this example, 4 and 5 we cannot reorder. Because it doesn't matter, because 4 will be root and only there one child, 5 will be, and again there is also like this, but we will create method ways called ways, and here will be this array like less, we named it, and there will be another array ways with greater array. In this fashion, we will solve this question. These methods will be recursive. Also, just by solving this question, we have this formula Cn minus 1r, but because we are solving it in by algorithm, it will be time consuming to solve it with a for loop, multiplying by 4, 3, 1, 2, and then dividing by 2, 1, or if it is a greater number, it will be time consuming first of all. Then next, we usually use long or int. We do not use double or float. Therefore, when we will divide by these numbers, it will get remainders, and it will not give us exact answer. Therefore, we have to use theory or strategy called Pascal's triangle. So what's basically Pascal's triangle? Pascal's triangle. So first, let's write numbers like 1, then again 1, then there will be 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and it continues in this fashion. Like we have to sum these numbers to get this, we have to sum these numbers to get this 3, we have to get 4, we have to sum these numbers. So this will be our zeroth row, this will be our first row. Why I'm saying this? So if this will be our locations, like we have 2 locations, 3 locations, 4 locations, and this will be our items. So for example, this is zeroth row. Like let's consider this will be our zeroth row column, this will be our first column, second, third, and fourth column. This Pascal's triangle help us to find the number of permutations. So this will be, for example, if we have 4 places, C 4 or 0. So like if we have 4 places and 0 items, in how many ways we can put 0 items in 4 locations? It will be 1, because only one way we can put 0 items. There is no another way. But if we have 1 item, there is a 1 item here. It's the first column. Rows are representing locations, and columns representing number of items. So if we have 1 item from 4 locations, we have 4 ways to place this item. For example, here I showed it. Now let's show it again. So there's 1, 2, 3, 4 locations, and to put 1 coin, we have 4 options. Like we can put here or here or here or here. There's a number of ways. So if this represents 4, 1, it will be 1. If we have two items, so this will be C42. It will show us 6 ways, in 6 ways. So this Pascal's triangle will help us to find very fastly our permutations. Okay. So next we will write the code, and then I will write the code in IntelliJ, and then I will just copy paste it to the LeetCode. So this solution is faster than most of the solutions in LeetCode. Why? Because we calculate this Pascal's triangle only once per submit. So it will have, for all the test cases, we will use this one array. We'll construct 2 by 2 array, but it will have to have memory, but it's not so big memory. Like here we have at maximum 1000 numbers in length of array. So we'll construct array that with dimensions 1001 and 1001. So let's dive into the code. First of all, let's create static array. It will be let's create from long. So long 2 by 2 array. Let's call it combinations. Let's check if video is continuing. Yes, it's continuing. Okay, combinations. And let's create method fill combinations. So it will return our array. Let's construct this. Create method fill combinations in solution. Okay, private static long. Also, we have to create static variable called, or we can, yes, okay, we'll create static variable mod. It will be also long mod equal to 1 billion plus 7. There will be 3, 4, 5, 6, 7, 8, and 7. So this is our 1 billion and 7. We have to place L there because it's Java. Okay. Or like VCal. So what's the problem? There is 1L already present. Okay. Next, let's create our Pascal's triangle. So it will be long. Let's call it array, 2 by 2 array, and it will have new long 1001. Why it's 1001? It's because it's a zero index. From zeroth index, it's like if we have 0 places and 0 items, how many ways we can reorder? It will be 1. And if we have 1000, it will be last element or last row, last column of our array. Therefore, we have to place 1001. Okay, and let's fill this array. The first element, it's 0 by 0, will be 1. Left elements will be zeros by default. Then let's create for loop int I equal to 1, I is less than 1001, I plus plus, for int j equals to 0, j less or equal than I, then j plus plus. It's again why we're placing j less than I. It's because I represents our locations, like free locations, our places, and the j represents our items. So it is not logical if our items will be more than our more than our locations. For example, if we have 5 or even 1 item but 0 places, in how many ways we can order one item in 0 places? Of course, it will be 0. Therefore, we don't have to fill these places. It's by default 0. Let's continue. So Let's create some variables like int a. It will be 0. So if I minus 1 is greater than or equal to 0 and j minus 1 is greater than equal to or 0, it will be, then our a will equal to array I and I minus 1, I minus 1, and j minus 1. It's we are just filling our int a. It have to be long. Okay. It just we are filling this array with in Pascal's triangle, how I showed before. Like here, for example, we can see that to fill this number 4, it is for one item, like first column. Zeroth column is 1 and 4 is first column. So if we have 4 locations and one item, if we have 4 locations and one item, the number of permutations will be 4. But how we calculate this 4? It will be this number 1 plus 3. So what is 3? 3 is there is a first column, but row is 3. Like I minus row, this is row 4, this is 3, so it's row minus 1, and the column, this column is 1, this column is also 1. But we also have to sum this one, 1. This one is again row is row minus 1, but column is 0. So it will be column minus 1. Therefore, we are calculating it in this fashion. Long b equals to 0. Okay, if j, this time j greater or equal to 0, then or no, not j, it will be I minus 1, I minus 1, because j will be the same. Okay, so b will be equal to array I minus 1 and j. Okay, so if this I minus 1 or I minus 1 j minus 1 is not out of bounds or of our length of array, so in this case we are decrementing it by 1, so it have to be greater than 0. But if it is less than 0 or it's minus 1 index, so it will just automatically be 0. 0 plus 0, it will give us like return 0, or if one of them is 1, we will get the correct number. So array, we are just filling this I, j will be a. We have to always mod by our value. Mod. Okay. Then plus b mod. Okay. We just filled our array. Then we have to return it. Return array. Okay. Okay. So we created. Now let's solve this. Write this method number of ways. It's our main method. So if we have nums, let's write size of nums. Int size equals to nums length. Okay, then int root will be our nums first value. It's a 0 indexed. Okay, then we have to create list. list list of integer with let's call it less new linked list. Okay. For int I equals 0, I less than size, I plus plus. If our number is strictly less than our root, so it will be in the left side of our binary search tree. So let's add it to this array, dynamic array. List add nums I. But if it is if else if nums I greater than root, then we have to I forgot to create integer to be greater. Okay, new linked list. Okay. Now we have to fill this dynamic array. So greater at nums I. Okay. We filled. Now we can calculate the result. So let's make some variable for this int and not int. Let it be long. Result equals to from combinations we take number, like it will be combinations. So it will be for row we have to place number of locations. Number of locations will be size minus 1. Why size minus 1? Because we the first number is root and the left places is size minus 1. Okay, next we can here place the number of this linked list less or greater. It doesn't matter because if we will place less, it will fulfill the other side. For example, let's show it here. For example, if we have uh, 1, 2, 3, 4, 5, 6, 7. So here basically we'll have 8 locations, and we'll have 3 coins. 1, 2, 3. These 3 coins are not different than this. These 3 coins are identical. So we can place these 3 coins here, like in any of these places. 8, then we multiply by 7, then we'll multiply by 6. So like 3 and divide by 3 factorial. So we'll get the same number of orders if we have not 3 coins but 5 coins. It's like free spaces. We also can count that as coins. But these 3 coins are, for example, red. For example, this coin was red. But these coins, 5, it will be black coins, for example. For example, if we will place these 3 coins in any order, we will have this number if the result. This left 5 coins will be placed automatically in the left locations. Therefore, it doesn't matter what we use here. So we can place there less size. Okay, then again we have to mod it by our mod. Okay, then multiply it by, we'll create method which we will call recursively ways, just ways. Okay, and there we will first send less, and again we will have to mod, then again multiply with ways, and here will be greater array. Then we have to again mod it. Okay. But when we multiply this place, we have to mod it again so that there will be no overflow. Okay, and then mod. Okay. Then again here we have to mod it again. In every step we have to just mod so that there will be no overflow. Okay, so we calculate our result, then we just return our result. This method, this have to be another method. I will just create this method. Let's cut this from there. Let's create method public in ways. Here we will pass as an argument in dynamic array to be list. Okay, we'll just put here. So there will be, we have to change a little bit, waste size. Okay, the root will be waste get 0. If list get I, okay, here's also okay, list get I, okay, list I. Where is our root is here. So result combination. Okay, let's return the result. Return. We have to just we'll get return this result. Then we will cast it when we will return it from our main method. There we have to return not int long. Okay, now here this method works fine, I think. Well, also, a base case, if our list is empty, then we just have to return 0. Return 0. Okay. Okay. So here, let's create nums list to list integer. Okay, let's call it list equals arrays dot stream nums like that box. It's just using streams to list. Okay, just we're using streams to convert array static array to dynamic array of a list. Then we can send. So let's write result long result equals to ways, and we send it list here list. Then we have to decrease it by 1 because our result in our example, it's already given one way, so we will just decrease it by one. Then we will return this as our answer. So it will be int. We have to cast it. So, okay, this is our solution. Let's place it. I cannot take here. I think this solution have to work. Number of ways, solution. Okay, let's just run. Oh, here's the runtime error. Why? Divide by 0. Okay. This mode is because it's static. I don't know why in the code. We just have to write this mode. Here's also this mode. Okay, let's run it again. Okay. This. Yeah, I can place here another long mode equals to this number. It doesn't matter. Here like this, it have to work. Oh, this is not correct. Okay, I will just pause the video and find where I have get mistaken. So I could find my mistake. So when a list is empty, we have to return 1 because we multiply it by every time 1 when it's empty, list is empty. But I write it to 0, but I will have to return 1. So if we run this code, it will get result of 1. Well, it's correct. When we submit, it will be correct. So I don't know why here's a very big solution like 349 milliseconds. Something is wrong with my algorithm here, but the basic idea is right. So before this I made a solution. It was 98%. It was very fast, 17 milliseconds. Here I just used instead of long integer, so it's less memory combinations. But when I was calculating the result, I just have to put long, so to avoid overflow every time, every time I have to divide it and mod it by this very big number. Then I get this result. This is my solution. I don't know what is not correct with this solution. Here we can see that few combination. I think, yes, I think it's because every time we are using array streams to convert this main array to list, and then we solve this map because of this, I think. So okay, thank you for your time. This is my first video. I think it was helpful, but there is another YouTube videos on the internet. So thank you. Goodbye.